something like, is that like something that doesn't like doesn't work, and like, before you've altered it, but it's not like, it's like
it's going to be recorded, but it says write out the following with those symbols, and this is the less than or greater than symbol. You've seen those before, yeah?
Yeah.
So just quick, so I didn't give it to you, it'll be super quick. Which one's bigger, 8 or 6?
8.
And which symbol do I use?
that left.
So this one.
Mix them up.
Crocodile. Yeah. Crocodile eats the bigger number. Right? Now, I won't go through any more of those because that's. So, how would we state x is greater than 8? So we do x is greater than 8. Now, this is the fundamental. This is what we need to look at. This is an inequality that is making a statement that says you are allowed to pick any number you like for x as long as it's greater than 8. Okay? So give me a number that I'm allowed to use. 999, 10, 80, whatever, yeah? Can I use 1? No. So when we say the difference between this and this is what?
It says that it's the exact same as 8, whereas with the that it means that x is any number bigger than 8. So it'll
Yeah.
be 8.
So this one only has one possible answer, which is x is 8. How many answers are there for this? An infinite number of answers. And that's the difference between what someone was saying, an equality. We tend to call that an equation. An equation says this equals something, and we can therefore work it out. But an inequality shares a lot of the same maths. However, it will have potentially an infinite number of answers. All right? So again, if we said x is greater than 5, we'd just be saying x is greater than 5. How many numbers are greater than 5? An infinite number. What about the x is less than or equal to minus 10? Or we say x is less than or equal to. Have you seen that symbol?
Yeah.
Okay, so the little line means you're also allowed minus 10. So in this case, 8 is not allowed. But in this case, negative 10 is allowed. Yeah, lots of other numbers, definitely. But in this case, any number bigger than 8, but not including 8. But this one would be any number less than negative 10, but you can have negative 10. Okay? All right? So it's basically like saying, like, if you had a test score, how do you get a 5? Well, let's say it's 50%. Well, if I get 50%, I get the 5. Or if I get above 50%, I've still got a 5. All right, so that would be an equal to. So we'll move on. That all makes quite perfect sense to you. Do you understand these number lines?
Yeah.
Seen them before? So what does this number line represent? So x is starts at 1. The arrow suggests we can use any number up. So x will be greater than 1. This one will be x is less than 3. Good question. I was waiting for that question. What do you think? So this would be x is less than and equal to. So basically a filled in dot means you're also allowed the number. If it's not filled in, you're not allowed the number. Simple as that.
So it could be.
So this is, you are allowed 5, but this one, you're not allowed 1. You only have to get above. Okay. And finally, we would say x is greater than or equal to 0. Okay. We've got lots more. I think you'll be. Let's just have a quick look at question 8. Look at this one. It says list all the integers that we're allowed, basically, that satisfy. So this one would just be 6, 7, 8, and 9. Are we allowed 5? Are we allowed 10? No. What about E? Minus 1, 0, 1, 2, and 3. Because it's got an equal to. So in this case, not allowed that one, but we are allowed that one. This one, not allowed either of them. Just the ones in between. And integers are whole numbers. Right, that all seems very good then. So let's go to the sheet that I've given you, which is, let's look at what x plus 4 is greater than 9 means. And I'm pretty sure you'll be quite quick with this. So if we say x plus 4 has to be greater than 9, well, basically that's what we're saying. The result of x plus 4 has to be a number larger than 9. So we're basically asking, what can x be?
Be anything greater than 6.
So we treat it like an equation. We say, well, we need to know the limit, the boundary, and we say x plus 4 equals 9. We're going to solve that, and that is x would equal 5, because we can minus 4 from both sides. So we can use that here and say, well, if x equals 5 makes 9, and I need a number greater than 9, I'm going to need a number greater than 5. And what I would always do with inequalities is I will check with a number greater than 5. So check with x equals 6, okay? And we do 6 plus 4 should be greater than 9. Well, 10 is indeed greater than 9, so I'm good to go.
What? You can go up to 1 million.
Yeah.
You can do x equals
Oh,
5.
so it's actually a million.
So how would I draw this as on a number line? I can. We don't need to
Well,
do
you're not
that.
using minuses.
So all we need to do with a number line is put the number. I'm going to put a 5,
So we form like
and I'm going to say x must be great. So actually, I did it the wrong side. I'm going to put it this way round. I'm going to put 5 there. Is my circle open or closed?
Open.
And I'm going to just put my arrow that way. I mean, I could write 6 and 7, but I think we know what numbers come above 5. So as long as we've got that 5, the open circle, and the arrow going in the right direction, that's how we do it. Okay. So let's have a look. So you've got lots there, nice and simple ones. Let's have a look at like one like this, 4x plus 8. So should we write that down together? 4x plus 8 is less than 32. So 4x plus 8 is less than 32. So the way to do this, I wrote it out as an equals. I'm actually just going to imagine, here's my little thought bubble, that that's an equals sign and treat it like it's an equals sign. So I'm then going to say, well, I just need to minus 8 from both sides, gives me 4x should be less than 24. Then I'm going to divide both sides by 4, gives me x should be less than 6. I'm then going to do a check. Now you can do this on paper or just mentally, at minimum mentally, okay? And say, well, 4 times, so I'm going to check with, give me a number less than 6. 3, okay? So I'm going to do 4 times 3 plus 8 should be less than 32 if I've got it correct. So 12 plus 8 is 20. 20 is less than 32. Looks like I'm correct. So I'm just going to finish this off with my number line. So x is less than 6, so I'm going to put a 6. I'm going to put an open dot, and my arrow is going to go in the less than direction. And there's my answer on a number line.
It's just like solving an equation.
It is just like solving
So did you
equations.
divide by 4 because you have 4 at the start?
I have 4 x's, yeah. I just want to know what 1 x is, yeah. What's the fundamental difference? Because there's not a lot of difference with how you do it, it's how you interpret it. So how many answers are there to 4x plus 8 is less than 32? What can x be? How many possibles?
Infinite.
An infinite. So there are an infinite number of answers. They just happen to all be less than 6. Okay? Now, obviously, things get a little bit more kind of challenging. Go back to here. But you hopefully will now have enough to at least do up to question 4. All right, happy to help if you need to. We probably will look at ones like question 5 after, maybe next lesson.
Okay.
Okay. I've got 2 x's and I've got 1, 2, 3, 4, 5, 6, 7. 1. Okay. 2 x's equals 14. Yeah? If I give you that equation, those 2 x's are equal to 14. What do we do?
You divide by 2, divide by 2.
So we divide it by 2,
Which is that.
which we get 1x is equal to 7. We've shared it out, yeah? So if I said, well, 2 x's, I don't know what they are, but I do know that 2 x's must be less than 14. So that means that 1x is going to have to be less than 7. All right? How many numbers are less than 7? An infinite number, including negatives and everything, okay? So when we are looking at these questions, okay, that's what we're trying to do. So if we say, if we know that, oh, what happened there? That's zoomed in a bit too much. If we know that 2 x's equals 14, how do you solve that? We do divide both sides by 2 and we get 1x must equal 7. I check that by doing x is 7, so 2 times 7 should equal 14. It does. I'm happy. All right? If I have x plus 4 equals 9, what do? Well, we subtract 4 and we say x equals 5. If I do my check, I say 5 plus 4 equals 9. It does. I'm happy. Okay? If I have one like 4x plus 1 equals 17. So we would minus the 1, gives me 4x equals 16. Divide by the 4, we get x equals 4. If I do my check, I check by saying 4 times 4 plus 1 should equal 17. It does. I'm happy. Now, for each one of those, these are all called equations. Because how many answers do we have for these equations? No, 1. I have found that one solution each time. However, what happens if I turn these equations into inequalities and I say, well, now 2x, instead of equaling 14, has to be, I don't know why you've got your device open.
I'm doing the,
Don't concentrate. Thank you.
and then do it at page.
Concentrate on me at the moment. Thank you. 2x is less than 14. Well, we've then got x must be less than 7. So instead of checking with x equals 7, I now need to check with a number less than 7. Let's say 6 if you want. I'm going to pick 3. 2 times 3, instead of equals 14, should be less than 14. 6 is less than 14. I'm happy. Turn this into an inequality. What if x plus 4 has to be greater than 9? Well, we've got x, therefore, must be greater than 5 to make that true. How do we check it? We're going to check with x being a number greater than 5. 6. Oh, boring. And then we say 6 plus 4 should be greater than 9. It is. I'm happy. What about this one? Well, let's turn it into an inequality. 6 plus 1 should be less than, so 4x plus 6, you've got it in my head. 4x plus 1 should be less than or equal to 17. Well, the equals is 4, so in this case we've decided that x should be less than or equal to 4. How do I do my check? 4 times, give me a number less than 4. 1. 4 times 1 plus 1 should be less than or equal to 17. 4 plus 1 is 5. 5 is less. So I think I'm correct. Okay? So when we are doing our inequalities, we're basically doing the equation that you've all done before, right? Using those methods. We're just, when we get to the end, we're considering there isn't one answer, there's a multiple, maybe an infinite number of answers. Okay? Would you like me to go through one more?
Yeah.
Okay. So let's look at G. X plus 3 divided by 2 is greater than 5. Okay?
X plus 3 divided by 2.
Which one?
X plus 3 divided by 2 is greater than or equal to 5.
Oh, we're on number 2.
Okay? Put your device down.
You didn't take negative 3.
Right, we can't minus 3 first. So we do, yeah, we need to times this by 2 first. So then we have x plus 3 is going to have to be greater than 10 or equal to. Now we can take away 3. So x should be greater than or equal to 7. We're now going to do a check with x equals what?
Oh, what?
Don't want to pick that number because that's what I've just found.
Be greater.
It's got to be greater than
I think it's 14.
14, okay? 14 plus 3, picked a horrible one, divided by 2 should be greater than or equal to 5. 40 is 17 divided by 2 should be greater than 5. What's 17 divided by 2? 8.5 should be greater than it, and it is, so I'm happy that I've done something. Okay?